we are Group 2. Now we are going to explain about fluorescence spectroscopy. This video consists of concept and principle, step by step on how to run the instruments, the analyze sample, and advantages and disadvantages of the instrument.
I'm going to explain about the concept and principle of fluorescence spectrometer. Fluorescence is a type of photoluminescence, which is the emission of light by a molecule. When a molecule absorbs UV radiation, it excites from ground state to excited state. Then, the excited molecule will fall back to ground state with the emission of a photon. Fluorescence happens immediately after initial photon absorption. The transition of electronic state of a molecule during the fluorescence phenomenon can be explained by using Jampolsky diagram. When UV radiation presents, the molecule will absorb the photon and excite from the electronic ground state to a higher excited state. After that, the electrons in molecule undergoes internal conversion and vibrational realization. As a result, the excess energy of the molecule transfers to a lower vibrational level. Then, the molecule emits a photon from lower singlet excited state to singlet ground state in the form of fluorescence. Basically, fluorescent molecule contains fluorophore, which is able to emit light. Besides, fluorescent molecule is unsubstituted aromatic hydrocarbons. When the number of benzene rings increase, the quantum efficiency increase. The presence of heavy halogen may stop the conjugation of pi electron and decrease the quantum efficiency.
For fluorescence is either fluorometer or spectrofluorometer. Common light source for fluorescence spectrometer is continuum source, line source, and also laser. Laser has the higher energy that cause the radiation to increase and make the signal stronger. Thus, as low as concentration is needed to be detected by the fluorescent. Wavelength selector that being used in this instrument for fluorometer is glass filter, while for spectrofluorometer is monochromator. Cuvette or flow cell is used as a sample holder. Detector use is either photomultiplier tube, which can only detect one signal at one time, or charge coupled device that can detect many signals at one time. Spectrofluorometer use high intensity light source to bombard the sample with as many photons as possible. This allows a maximum number of molecules to be excited at any one point in time. The light is passed through an excitation monochromator, which allows wavelength of interest to be selected for use as the exciting light. The emission also passed through an emission monochromator before being detected by PMT or CCD.
The analyst must have several properties to make sure it is suitable to be analyzed. First, the analyst must be able to absorb in solvent like water, ethanol, or hexane to form aqueous solution. Second, the analyst must be able to absorb UV or visible light and does not have any photochemical reaction at the wavelength range of interest, which is around 180 to 800 nanometer. Besides, the structure of the analyzed molecule must be rigid. If it is not rigid, the fluffiness of molecule will allow more vibrational interaction and internal convection rate, which will increase the fluorescence activity. However, some of the chelating agents will only fluoresce when they are bound to a central metal atom. For the determination of fluorescence photometer, the analyst must be luminescent substance. Luminescent substance is the emission of light by a substance when an electron returns to its electronic ground state from an excited state and lost its energy as photon. However, they are not all of the luminescent substances are fluorophores. Fluorophores are usually contain several combined aromatic groups or planar or cyclic molecules with several pi bonds. For example, nathalene and aniline.
Moving on to disadvantages and advantages of fluorescence spectroscopy. One of the main advantages of using this instrument is that it has high sensitivity and high specificity. Besides, its fast and rapid diagnosability is what makes it more preferable than the other instruments. However, the main disadvantage of this instrument is that it can only read compounds that can fluoresce. So, if you have other compounds that cannot fluoresce, the instrument cannot read or detect the analytes. Currently, almost every procedure available to diagnose microorganisms has some barriers that should be overcome. But studies state that fluorescence spectroscopy has already overcome some of the limitations, and in the future, this technique has the potential to be improved. For example, by integrating optic fiber, this instrument can be used to diagnose microorganisms in vivo. Besides, another future improvement that can be done is the automatization of these instruments, which makes it possible to analyze many samples at one time. That's all. So, we have learned about concept and principle and step by step on how to run the instrument. I hope that you can learn something from this video. Thank you.